Our fourth lecture video on work, power, and energy will cover a couple of different power calculations. The mass of materials a crane moves is 7,250 kilograms. What power is used to raise the materials to a height of 35.0 meters if the work is done in 32.0 seconds? Writing down all of our data first, we see that the mass is 7,250 kilograms. The displacement S is 35.0 meters. The time it takes to move the materials is 32.0 seconds, and we are trying to calculate the power. The basic equation we need to calculate power is that power is equal to work divided by time, which is the same thing as force times displacement divided by time. However, in this problem, we aren't given the force. Instead, we are told what the mass is. Since the materials are being lifted vertically, the force we need is actually the weight force of the materials. To find the weight force, we can take the mass of materials and multiply that with the acceleration due to gravity, so F equals m times g will be our second basic equation that we need. We will substitute in for force first and then substitute the value for force into the first equation for power. Force is equal to the mass of 7,250 kilograms times the acceleration due to gravity, which is 9.80 meters per second squared. This gives us a force of 71,100 kilogram meters per second squared, or, reducing the units, 71,100 newtons. Now that we have the force calculated, we can find the power by taking 71,100 newtons times the displacement of 35.0 meters, all divided by the time of 32.0 seconds. This gives us an answer of 77,800 newton meters per second. We don't usually talk about power in terms of newton meters per second or joules per second. This is the same thing as 77,800 watts, which is usually the unit we express power in. However, since this answer is such a large number, we want to change the metric prefix. 77,800 watts is the same thing as 77.8 kilowatts. So the power to raise these materials is 77.8 kilowatts. The last example on power we will take a look at states that a machine is designed to perform a given amount of work in a given amount of time. A second machine is designed to perform 3 times the work in 3/4 of the time. Find the power of the second machine compared to the first. Even though we aren't given specific numbers for our calculations, we can still find a power ratio for this problem. We know that the work W of the second machine is 3 times the work, or 3W. We also know the time to complete the work is 3/4 the time, or T equals 3/4 T. We are trying to find the power ratio P. The basic equation for power is that power is equal to the work performed divided by the time to perform the work. We can substitute in our values for W and T. This gives us that power is equal to 3 times W divided by 3/4 times T. This is equal to 4 times the work divided by the time. But we know that work divided by time is power, so this is equal to 4 times the power. That means that the second machine develops 4 times as much power as the first machine. This concludes our lecture and examples on power.